Let's say we have any function f and we try to find the derivative with the standard derivative notation, which is we take the limit as h approaches zero of f of x plus h minus f of x all over h. Now, we know how to find the derivative of a single function, but how would we do this with the derivative of two functions? For example, the derivative of f times another function g, and I want to find the derivative of that. What would that equal to? Well, we can do pretty much the same thing we did right here with this. So as you can see, to take the derivative of a function f times any other function g, we just do pretty much the same thing we did over here, but we times everything by the function g as well. So we take the function f with the input x plus h times function g with input x plus h minus f of x times g of x all over h. So we just multiply every f term with every g term, which makes sense, right? Now, to make this a little bit simpler, we have to make this top numerator a little more complex. By doing that, we can, for example, add by 0. Now, this term might look a little complex, but this middle term right here, all it's doing is adding by 0. This minus f of x plus h times g of x plus f of x plus h times g of x, that is basically just saying, okay, take this and add 0 to it. Just take this whole thing and just add 0. That is what we're doing right here. We're just taking this, adding, it does not change the value at all. We're just adding 0 to make this a little bit easier to manipulate. So what we can do is we can actually, because we added this term right here, we can actually just factor out something in these two first terms and factor out something in these two second terms. Notice in these two first terms, we have a common factor of f of x plus h. We have f of x plus h right here, and we have f of x plus h right here. And we can factor this out of these two terms. And also in these two terms, we can factor out a g of x right here, and another g of x right here. So if we factor out these two terms and split the limit, we end up with this. Just pay attention to this top part right here. If we fully distribute this f of x plus h to this term and this term, you notice we can get this term right back. Also, as you can notice right here, if we distribute this g of x to this f of x plus h and g of x to minus f of x, we can get this term back right here. So notice we just didn't do anything. We just factored out a g of x and an f of x plus h. But also, what we can do here is we can just take out this f of x plus h from this numerator and just make it a scalar that we're multiplying the whole fraction by. And also, we can take a g of x out of this numerator and just make it a multiple of this numerator, as these equal the same thing. So where can we go from here? Well, we can split this limit even more into each individual term and see what that evolves to, and see what that evaluates to. So, as we can see right here, we just split each term, and we want to find the limit of each term. So we just want to find the limit. And we will just evaluate this right here, right now. So the limit of f of x plus h, what would that be? Well, right here, we can just substitute in h for 0, right? We can just make it equal to 0. Because we're not dividing by 0, right? So we can just substitute it in, and it won't make any difference. So that would just equal to, that limit would just equal to f of x. And now this limit would equal, let's see, this is the definition of a derivative for the function g. As we see right here, the definition of a derivative for f in this context is the same exact thing for what this is a definition of a derivative for g. So this is just a derivative of g because it is the literal definition of a derivative. And also right here, because we don't even have an h in this term right here, the limit would just equal g of x. And then we can see right here in this final limit how this, just as we discussed up here, is the exact same thing as the definition of the derivative for the function f. So this would just equal to f, the derivative of f. And just remember that we're multiplying these two terms and multiplying these two terms and adding them up. And now this is the product rule that we are all familiar with. And these are the evaluations of the limits. And so this is how the product rule arises from just simple manipulation of multiplying different functions and finding their derivatives.